In the name of Allah, the most merciful and most beneficent. Here is Mrs. Sania Latif, SS Chemistry in DPS Sahiwal. In subject chemistry, we are discussing chapter 3, gases. Today's topic of our lesson is plasma state, key points of our chapter, and some questions from exercise. Plasma, the fourth state of matter. Objectives of our lesson are: students will be able to understand the fourth state and the master state of the matter. They will know the composition of the plasma, how plasma is formed, and what are the characteristics of the plasma. My dear students will be able to know the applications of plasma in our daily life. For this purpose, first of all, we will recall the basic forms of matter which we observe all around us. Dear students, in case of solid, पार्टिकल्स एक दूसरे के बहुत करीब होते हैं, इनकी पोजीशंस फिक्स होती हैं और सॉलिड पार्टिकल्स अपनी ही पोजीशंस पे वाइब्रेट करते रहते हैं. दे डोंट मूव हियर एंड देयर. बट व्हेन वी प्रोवाइड हीट टू द सॉलिड, द इंटरमॉलिक्यूलर स्पेसेस becomes less, their positions are now no more fixed, and the liquid particles move randomly. Providing more heat, the liquid is turned into gas, and these particles now have very less interactions. And in this gas, a single particle, when provided more heat, the atom decomposes, and the gas atoms are converted into positive ions and negative electrons. When electrodes are provided, positive ions go to the negative electrode and electrons go towards the positive electrode. This state of matter in which atoms of the gas are decomposed, are turned into their respective ions, like positive nuclei and electrons are separated from each other. This state of matter is called plasma. What is plasma? Plasma is often called the fourth state of matter, the other three being solid, liquid and gas. हम सब जानते हैं गैस, लिक्विड और सॉलिड सब्सटेंसेस हमारे इर्द गिर्द हर जगह मौजूद हैं, लेकिन आज हम मैटर की फोर्थ स्टेट प्लाज्मा के बारे में सीखेंगे कि प्लाज्मा क्या है. प्लाज्मा was identified by an English scientist, William Crookes, in 1879. Inventors have used plasma to conduct electricity in neon signs and fluorescent bulbs. Scientists have constructed special chambers to experiment with plasma in laboratories. Occurs only in lightning, discharges, and in artificial devices like fluorescent lights, neon signs, etc. प्यारे बच्चों, प्लाज्मा स्पेस में हर जगह मौजूद है. Plasma is actually the matter of space. It is the most abundant material present in this universe. How is plasma formed? जब हम सॉलिड को हीट प्रोवाइड करते हैं, सॉलिड मेल्ट्स इनटू लिक्विड. जब हम लिक्विड को हीट प्रोवाइड करते हैं, लिक्विड टर्न्स इनटू गैस. और जब हम गैस को हीट प्रोवाइड करते हैं, व्हाट हैपेंस? When more heat is applied, the atoms or molecules of a gas are ionized. जरूरी नहीं है कि सारे के सारे मॉलिक्यूल्स जो हैं वो आयनाइज हो जाएं. All the atoms are not necessarily ionized. Some of them may remain completely intact with no net charge. जब हम गैस को बहुत ज़्यादा हीट प्रोवाइड करते हैं तो उस गैस के चंद एटम्स जो हैं वो डिकम्पोज होकर पॉजिटिव आयंस और नेगेटिव आयंस प्रोवाइड करते हैं, चंद एक एटम्स हैं वो इंटैक्ट जो है वो रह जाते हैं, तो इस मिक्सचर को जो है वो हम प्लाज्मा कहते हैं. So this ionized gas mixture consisting of ions, electrons and neutral atoms is called as plasma. Ionized gas mixture consisting of ions, electrons and neutral atoms. गैस को हीट प्रोवाइड करने से, एटम्स के डिकम्पोज होने से, एटम्स के टूटने से जो आयंस बनेंगे, जो इलेक्ट्रॉन्स वहां से निकलेंगे और वो एटम्स जो न्यूट्रल रह जाएंगे, जो आयोनाइज नहीं होंगे, इन सब के मिक्सचर का नाम है प्लाज्मा. It means that a plasma is a distinct state of matter containing a significant number of electrical properties and behavior. Due to the presence of ions and electrons, plasma shows a significant property, electrical property and behavior. How plasma is formed? Look at this diagram, students. This is a neutral atom. There is the nucleus present in the center of this gaseous atom and the electron is revolving in its orbit around this nucleus. When this atom is provided with a very high temperature, this atom converted into a cation and electron. Nuclei and electrons of the atoms get separated from each other. Now, this mixture of positive ions and negative ions of the gas is called as plasma. This plasma has high energy. What plasma can potentially do? Plasma can generate explosions because plasma has very high energy. In nature, cold plasma also exists, so plasma can also freeze the substances. Due to the presence of cations and electrons, plasma can carry electrical currents. Due to the presence of moving charged particles, plasma supports magnetic field. Space plasma can melt the earth thousands of times over. Space plasma इतना heated है कि वो हमारी जमीन को हजारों दफा मेल्ट कर सकता है. क्रिस्टल प्लाज्मा इतना ठंडा है कि वो हमारी जमीन को सैकड़ों बार फ्रीज कर सकता है. Natural plasma can exist only at very high temperature or at very low temperature vacuums. Natural plasma, on the other hand, do not break down or react rapidly, but are extremely hot over 20,000 Celsius minimum. Natural plasma which exists in this space can have 20,000 Celsius minimum temperature. प्लाज्मा के अंदर एनर्जी इतनी ज़्यादा है कि कोई भी सब्सटेंस जो इस प्लाज्मा को स्ट्राइक करेगी, इसको टच करेगी, दे कैन बी वेपराइज्ड, वो वेपराइज हो जाएगी. Characteristics of plasma. Dear students, due to the presence of neutral atom, cations and electrons, there are some special characteristics of plasma. पार्टिकल्स की मोशन की वजह से प्लाज्मा के अंदर इलेक्ट्रिक और मैग्नेटिक फील्ड्स जनरेट होती हैं. किस हद तक या किस स्ट्रेंथ की ये फील्ड्स डेवलप होंगी, इट डिपेंड्स अपॉन द प्लाज्मा डेंसिटी. जितना ज्यादा प्लाज्मा डेंस होगा, चार्ज पार्टिकल्स की कंसंट्रेशन अमाउंट जितनी ज्यादा होगी, इन फील्ड्स की स्ट्रेंथ भी उतनी ज्यादा होगी. This complex set of interaction, what do you mean by complex set of interaction? Presence of neutral atoms, cations and anions in the same gas makes plasma a unique, a fascinating and a complex state of matter. Although plasma includes electrons and ions and can conduct electricity, it is macroscopically neutral. In measurable quantities, the number of electrons and ions are equal. In measurable quantities, the number of electrons and ions are equal. That's why plasma is macroscopically neutral. Where is plasma found? Plasma is found in lightning. When lightning takes place, the gases of the atmosphere are converted into plasma. It is present in flames. It is present in auroras. Dear students, plasma is the stuff of stars. Our sun is 1.5 million kilometers ball of plasma. There is plasma all over in the sun. It is matter of interstellar space. सिर्फ सितारों के अंदर नहीं, सितारों के दरमियान भी जो मैटर है वो भी प्लाज्मा है. Plasma is present in fluorescent lights. Gases are filled in these tubes. When electric current passes through these tubes, the gases are charged and excited, and the gas is converted into plasma, which produces glow of different colors. Dear students, now let me share some applications of plasma with you. There is a fluorescent light bulb which we can see in our homes, in our offices. The spiral tube of this fluorescent light bulb is not like a regular light bulb. Inside this long tube, a gas is filled. When the light is turned on, electricity flows through the tube. This electricity acts as that special energy and charges up the gas. The gas within this tube, when electric current is passed, the gas is excited. The gas charged up. This charging and exciting of the atoms creates a glowing plasma inside the bulb, and this bulb produces glowing light. We can see neon signs all over the roads. What are actually the neon signs? Neon signs are glass tubes filled with gas. When they are turned on, then the electricity flows through these tubes. The electricity again charges the gas. Possibly the gas may be neon. Other inert gases can also be filled in these signs. This electricity charges the gas and creates a plasma inside the tube. इस तरह से जो प्लाज्मा बनता है, that glows a special color depending on what kind of the gas inside the neon tube. Dear students, they find applications such as plasma processing of semiconductors, sterilization of some medical products, lamps, lasers, diamond-coated films, high-power microwave sources, and pulsed power switches. They all have plasma in them. The very important application of the plasma is that they provide the foundation for important potential applications such as generation of electricity. This is very important use of, very important application of plasma, that the plasma helps us in generation of electricity. What are the future horizons for plasma? The magnetic fields create low energy plasma which create molecules that are in what scientists call a metastable state. मैग्नेटिक फील्ड से लो एनर्जी प्लाज्मा क्रिएट किया जा रहा है जिसे मेटास्टेबल स्टेट कहा जाता है. What is actually the metastable state? This is an excited state. This is an excited state with a long life. Magnetic fields used to create the low temperature plasma give the plasma molecules, electrons which do not react until they collide with another molecule with just the right energy. इस तरह से metastable molecules are able to survive for a long time with a designated molecule. Metastable particles are very selective in their reactivity. This is very important for metastable particles. It makes them a potentially unique solution to problems like radioactive contamination. This is the only method to remove radioactive contamination. No other solution for this problem. Scientists are currently experimenting with mixtures of gases to work as metastable agents on plutonium and uranium, and this is just the beginning. What happens later? Dear students, now we will solve some questions from exercise. This is all about plasma. Question number 1 is choose the correct answer from the given options. Very first statement is pressure remaining constant at which temperature the volume of a gas will become twice of what it is at 0 Celsius. अगर हम प्रेशर को कांस्टेंट रखेंगे तो किस टेम्परेचर पे गैस का वॉल्यूम डबल हो जाएगा उस वॉल्यूम से जो कि 0 सेल्सियस पे था. ऑप्शंस आर 546 सेल्सियस, 200 सेल्सियस, 546 Kelvin, 273 Kelvin. The answer is 546 Kelvins. Dear students, we will use the relationship V1 over T1 is equals to V2 over T2. Supposing V1 is X, then V should be 2X. V1 is X, V should be 2X, V should be double. So, T1 is 273 kelvins. What should be the T2? T2 should be 546 kelvins. T2 should be 546 kelvins. Next statement is number of molecules in 1 dm cube of water is close. How many number of molecules in 1 dm cube of water is present? Options are 6.22 over 22.4, 12.04 over 22.4 into 10 raised to power 23, 18 over 22.4 into 10 raised to power 23, or 55.6 into 6.02 into 10 raised to power 23. The answer is 55.6 into 6.02 into 10 raised to power 23. Dear students, we know that number of molecules are equals to moles into Avogadro's number, and 1 dm cube of water contains number of mole 55.6 multiplied by Avogadro's number. So the correct answer is 55.6 into 6.02 into 10 raised to power 23. Third statement is, which of the following will have the same number of molecules at STP? 280 cm cube of carbon dioxide and 280 cm cube of nitrogen dioxide, 11.2 dm cube of oxygen and 32 grams of oxygen, 44 gram of carbon dioxide and 11.2 dm cube of carbon monoxide, 28 gram of nitrogen and 5.6 dm cube of oxygen. The answer is 280 cm cube of carbon dioxide and 280 cm cube of NO2. Why they have same number of molecules at STP? Because their volumes are same, and as well as both gases have same molar mass, that is 44 grams per mole. दोनों का मोलर मास सेम है. जब मोलर मास सेम है तो दोनों के नंबर ऑफ मॉलिक्यूल्स भी सेम होंगे. नेक्स्ट स्टेटमेंट इज, if absolute temperature of a gas is doubled and the pressure is reduced to half. टेम्परेचर को डबल करना है और प्रेशर को हाफ करना है. The volume of the gas will be, it remains unchanged, increases 4 times, reduced to 1/4, or be doubled. The answer is increases 4 times. Why it increases 4 times? Because we are changing both the conditions. It will be double if absolute temperature of a gas is doubled. The volume will get double when the temperature is doubled. It will increase 4 times when pressure is also reduced to half. How should the conditions be changed to prevent the volume of the given gas from expanding when its mass is increased? The temperature is lowered and pressure is increased. Temperature is increased and pressure is lowered. Temperature and pressure both are lowered. Temperature and pressure both are increased. Dear students, the answer is temperature is lowered and pressure is increased. Mass बढ़ाने से टेम्परेचर को कम करना होगा और प्रेशर को बढ़ाना होगा ताकि गैस को एक्सपैंड होने से बचाया जा सके. Molar volume of carbon dioxide is maximum at STP 127 Celsius and 1 atmospheres, 0 Celsius and 2 atmospheres, or 273 Celsius and 2 atmospheres. The answer is 127 Celsius and 1 atmospheres. वॉल्यूम फाइंड करने के लिए हम इक्वेशन यूज करेंगे V इज इक्वल्स टू nRT ओवर P. तो हम सारी कंडीशंस के साथ इसका वॉल्यूम फाइंड करेंगे विद स्टैंडर्ड टेम्परेचर एंड प्रेशर. देन वी विल फाइंड वॉल्यूम by using temperature 127 Celsius and 1 atmosphere. Then we will calculate volume by using conditions 0 Celsius and 2 atmospheres. At the end we will calculate volume by using the condition 273 Celsius and 2 atmosphere. The volume is maximum at these conditions. Maximum volume is 32.84 at 127 Celsius and 1 atmosphere. So the answer is the molar volume of carbon dioxide is maximum at 127 Celsius and 1 atmosphere. The order of the rate of diffusion of gases ammonia, sulfur dioxide, chlorine and carbon dioxide is? Dear students, the correct order is ammonia is greater than carbon dioxide, is greater than sulfur dioxide, is greater than chlorine. जैसा कि हम जानते हैं मोलर मास जितना छोटा होता है रेट ऑफ डिफ्यूजन उतना ज्यादा होता है. Look at 17 smaller mass of ammonia, then carbon dioxide, then sulfur dioxide, then chlorine. So the correct order for the rate of diffusion of these gases is B. Equal masses of methane and oxygen are mixed in an empty container at 25 Celsius. The fraction of total pressure exerted by the oxygen is. हमने एक कंटेनर में मीथेन और ऑक्सीजन के इक्वल मैसेस को ऐड किया है, तो उन इक्वल मैसेस में ऑक्सीजन का प्रेशर फ्रैक्शन क्या होगा? It should be 1/3, 8/9, 1/9, or it may be 16/17. The answer is 1/3. The pressure exerted by the oxygen is 1/3 of the total pressure. Dear students, a ratio of mole fractions between methane and oxygen is 0.5:1.5. So the pressure will be in the ratio of 1:3. Gases deviate from ideal behavior at high pressure. Which of the following is correct for non-ideality? Non-ideality के लिए कौन सी statement correct होगी? At high pressure, the gas molecules move in one direction only. At high pressure, the collisions between the molecules are increased manifolds. At high pressure, the volume of the gas becomes insignificant. At high pressure, the intermolecular interactions become significant. So, what is correct for non-ideality? The answer is D. At high pressure, the intermolecular interactions become significant. This statement is correct for non-ideality because at high pressure, the development of the intermolecular forces make the gas non-ideal. The deviation of gas from the ideal behavior is maximum at. Options are -10 Celsius and 5 atmospheres, -10 Celsius and 2 atmospheres, 100 Celsius and 2 atmospheres, 0 Celsius and 2 atmospheres. As we know that for an ideal gas, the deviation is maximum at low temperature and at high pressure. So in these options, the least temperature is -10 Celsius and the highest pressure is 5 atmospheres. So the correct answer is A. A real gas obeying van der Waals equation will resemble ideal gas if both A and B are large, both A and B are small, A is small and B is large, A is large and B is small. What should be the correct answer? Both A and B are small. Dear students, आइडियल गैस van der Waals इक्वेशन को आइडियल गैस इक्वेशन के करीब लाने के लिए both factors A and B should be small. Hint for this reason is if both are 0, gases become ideal. अगर A भी 0 हो जाए और B भी 0 हो जाए तो van der Waals इक्वेशन और आइडियल गैस इक्वेशन सेम हो जाएंगी. So For obeying van der Waals equation, a real gas for obeying van der Waals equation should have both A and B factors small. Now question number 2 from exercise. We have to fill in the blanks with appropriate answer. The product PV has the SI units. Dear students, as we know, the SI unit for pressure is Newton per meter square and the unit for volume is m cube. The SI unit for PV, product PV, should be Newton meter. 8 grams each of oxygen and hydrogen at 27 Celsius will have total kinetic energy in the ratio of 1:16 because oxygen is 16 times heavier than hydrogen. Dear students, smell of cooking gas during leakage from a gas cylinder is due to the property of dash of gases. हमें कैसे पता चलता है कि सिलेंडर लीक कर रहा है, हमें उसकी स्मेल कैसे पहुंचती है, कौन सी प्रॉपर्टी है गैसेस की? That property of gases is diffusion. Due to diffusion, the particles, we can feel the smell of the cooking gas. Equal dash of ideal gases at the same temperature and pressure contain dash number of molecules. Equal volumes of ideal gases at same temperature and pressure contain equal number of molecules. The temperature above which a substance exists only in a gas is called critical temperature. Below this temperature, the gas turns into liquid, and above this temperature, the gas exists in its gaseous state only. Now, question number 3 from the exercise. We have to label the statement as true and false. First statement is kinetic energy of molecules of a gas is 0 at 0 Celsius. क्या ये possible है कि molecules की kinetic energy 0 हो जाए? No, it is not possible. Energy of molecule cannot be 0 at any temperature. So, the statement is false. Next statement is a gas in a closed container will exert much higher pressure at the bottom. क्या ऐसा होता है कि गैस का कंटेनर के बॉटम पे ज्यादा प्रेशर होता है एज कंपेयर टू वॉल्स? नो, ऐसा नहीं होता. गैस पार्टिकल्स पे ग्रेविटी का कोई इफेक्ट नहीं है कि पार्टिकल्स जो हैं वो कंटेनर के बेस पे ज्यादा जो है वो प्रेशर एक्सर्ट करें. They are free to move all the free volume available within the vessel. They are free from force of gravity. So, the statement is false. Real gases show ideal behavior at low pressure and high. Real gases show ideal behavior at low pressure. Low pressure changes the non-ideal behavior towards the ideal. So both these two conditions are suitable for the real gases to behave ideally. So the answer, true statement. Liquefaction of gases involves decrease in intermolecular spaces. Yes, when the intermolecular spaces of gas molecules will decrease, they come close to each other and then they will turn into liquid. So the answer, true. An ideal gas on expansion show Joule-Thomson effect. No, ideal gas can't show Joule-Thomson effect on expansion. Now, question number 15 from exercise. There are few statements and we have to justify or we have to explain these statements. The first statement is The plot of PV to P is a straight line at constant temperature and fixed moles of an ideal gas. क्यों PV to P graph line straight क्यों होती है? For an ideal gas, because for an ideal gas, the change in pressure changes the volume. Change in pressure changes the volume. For an ideal gas, change in pressure changes the volume exactly same. So, product PV remains constant and graph shows straight line. जितना प्रेशर बढ़ेगा वॉल्यूम उतना कम होगा. प्रेशर जितना कम होगा वॉल्यूम उतना बढ़ जाएगा. तो इन दोनों का जो प्रोडक्ट है वो सेम रहेगा. That's why the graph shows straight line. The straight line goes away from the pressure axis at higher pressure for many gases. High pressure पे gases deviation क्यों show करते हैं? Because at higher pressure molecules come close and intermolecular interactions are developed between the molecules. Now molecules are not free to move and they don't have enough intermolecular spaces among themselves due to the intermolecular interactions. So the gases show deviation from the straight line. Third statement is pressure of ammonia at 20 atmospheres and at room temperature is less as calculated by van der Waals equation than by general gas equation. Van der Waals equation से जो प्रेशर हम अमोनिया के लिए कैलकुलेट करते हैं वो कम आता है जब हम प्रेशर जो वो जनरल गैस इक्वेशन से कैलकुलेट करते हैं. Dear students, ammonia is a non-ideal gas and it show deviation from ideal behavior. Its pressure is less. Why its pressure is less? Because exert less pressure due to the presence of a special type of intermolecular force of attraction between ammonia molecule, that is hydrogen bonding among the gas molecules. Due to the presence of hydrogen bonding among the ammonia molecules, it exerts less pressure. It shows deviation from ideal behavior. Water vapors do not behave ideally at 273 Kelvin. Dear students, 273 Kelvin means 0 Celsius temperature, which is the freezing point of water. So vapors turn their state and they don't behave ideally. This temperature is very low and the state of the gas is changed and they behave non-ideally. SO2 behaves non-ideally at 273 Kelvin but becomes ideal at 372 Kelvin. Dear students, as we know very well, by increasing the temperature, intermolecular forces of gases, intermolecular forces become low and the gases show ideal behavior, and it show ideal behavior at 327 Kelvin. Dear students, we also have to solve question number 22. Calculate the number of molecules and number of atoms in given amounts of each gas. The first data is 20 cm³ of methane at 0 Celsius and pressure of 700 mm of mercury. Volume given is 20 cm³. We have to convert it into 0.02 dm³. Pressure given is 700 mm mercury. We have to convert it into atmospheres, 0.92 atmospheres. The value of R is given and the temperature is 0 Celsius. We have to convert it into kelvins, 273 kelvins. We have to calculate the number of moles. For this we will substitute the values in ideal gas equation. PV is equals to nRT. The number of moles will be equal to PV over RT. Substituting the values P is 0.92, volume is 0.02, and value of R is 0.0821, and the temperature is 273 kelvins. The number of moles are 0.00820 moles. Number of molecules is equals to number of moles into Avogadro number. Number of moles are 0.000820 and Avogadro number is 6.02 into 10 raised to power 23. The answer will be 4.936 into 10 raised to power 20 molecules. For calculating the total number of atoms, we have to multiply the number of molecules with the number of atoms in one molecule. As we know, in case of methane, there are 5 atoms in one molecule, 1 atom of carbon and 4 atoms of hydrogen. We will multiply the number of molecules with number of atoms. The total atoms will be 24.7 into 10 raised to power 20 atoms. The B part of this question is 1 cm cube of ammonia at 100 Celsius temperature and pressure is 1.5 atmospheres. The volume is 1 cm cube. We have to convert this 1 cm cube into dm cubes. Pressure is 1.5, R is 0.0821 dm cubes atmospheres per Kelvin per mole, and temperature is 100 Celsius. We have to convert it into kelvins by adding 273. The answer will be 373 kelvins. For calculating the number of moles, the equation is PV over RT, putting the value of pressure, volume 0.001, R 0.0821 and temperature 373. The number of moles of ammonia are 0.000048 moles. So, for calculating the number of molecules, we have to multiply number of moles with the Avogadro number, the number of moles and the Avogadro number. The number of molecules will be 2.94 into 10 raised to power 19 molecules. In order to calculate the number of atoms, we have to multiply again number of molecules into number of atoms in one molecule. Now, ammonia having 4 atoms in one molecule, 1 atom of nitrogen and 3 atoms of hydrogen. We will multiply these number of molecules with 4 to get total number of atoms, that is 1.177 into 10 raised to power 20 atoms. Recapitulation. Dear students, in this chapter we have read the behavior of gas is described through 4 variables: pressure, volume, temperature and its number of moles. General gas equation about the behavior of gas is obtained. PV is equals to nRT. In this chapter, Dalton's law of partial pressures can be used to calculate the partial pressures of the gases. The processes of diffusion and effusion are best understood by Graham's law of diffusion. Gases become non-ideal at high pressure and at low temperature. Gases can be liquefied by applying sufficient pressure, but temperature should either be critical or below it. Alternative kinetic equation is known as the van der Waals equation, which is only applicable on the real gases. At the end of the chapter, we have learnt about the plasma, the 4th state of matter, consisting of neutral particles, positive ions and negative electrons. Dear students, 99% of the known universe is in the state of plasma. Today's assignment for my dear students is how plasma can be produced artificially. Think about that. how plasma can be produced. Second question is, dear students, you have to enlist the objects in which plasma is found all around us. In the third question, you have to find the composition of the plasma to understand the properties and characteristics of the plasma. This is all from my side. Thank you very much. Allah Hafiz.